What is the help of the functional interface? Let's say we want to have a single method, and that method will be implemented with the Lambda expressions in a different ways, and we can store them into the different references. So let's take an example of the calculator, right? In calculator, we want to have a different operations. We want to perform different operations for the two numbers. Sum the two numbers, subtract, divide, and multiply. So what we can do, we can create a functional interface with a single abstract method, and we can implement that method with the Lambda expression and store it to the different references. Let's create a calculator interface. So this interface will have a single abstract method. We will make this as a functional interface. It will return integer, and we will say calculate. We'll take two parameters, int num1, int num2. So this method will be implemented with the Lambda expression. Let's now create a class calculator test. So we'll create a main method, and here, so we'll implement here a abstract method. So we'll say calculator, we'll say addition. We'll implement this with the parentheses. For two parameters, we'll put parentheses. If it will be a single parameter for that method, then we will not need any parentheses. So we'll say x for the num1, y for the num2. And here we'll say return x plus y. So it will complain. The reason it is complaining because we have a single line of code, but when you have a single line of code and don't have a curly braces, we don't need to use the return keyword here. We can just directly say x plus y. The next time, we can implement the same method from the calculator functional interface for a subtraction purpose, right? So we'll say take the two parameters, which is x and y, and subtract x by y, right? So this will be for a subtraction. And the next one will be for a multiplying. Say x comma y, return x multiplied by y, right? So, and the next one will be calculator divide equals to x y, and we will divide x by y, right? So we have four different references with the different implementations. Now let's try to test them, saying addition dot calculate 2 by 2, right? And the next one will be subtract, let's say 3 by 2. Next one will be the multiply, 5 by 2. And the next one will be the divide, let's say 10 by 2, right? So we'll divide 10 by 2. Let's run it now. You will see the same method, different implementation. And we'll have the output for the addition. 2 plus 2 is 4. For the subtract, 3 minus 2 is 1, right? And so on. They are properly calculated. But let's say we will have a method which is divide, right? Divide, calculate 5 divided by 0. If we will divide any number by 0, it's not possible in the math, and we will get some arithmetic exception in Java saying divide by 0. For this reason, we gotta implement a method body here saying if the y is 0, then give us -1. If y is not 0, then divide the numbers. So we'll have multiple lines in the method body, so we will need to use a curly braces. So in this curly brace, we will need to implement this method. So we will say if y is equals to 0, then return -1. Else return whatever the output of x divided by y, right? So here we see that we use the return keyword because we use multiple lines and we put the curly braces. Right, let's run it now, and we will see that 5 by 0 will have a -1 as an output. Yep, this is how we can, use a single abstract method in functional interface and implement that with the Lambda expression with the different ways.